Really important that you go through and really memorize those polyatomic ions, formulas, and names as well. There's one more type of, or subtype of ionic compound that we want to talk about, and it really isn't a brand new type. Instead, it's just a combination of some things we've already talked about. It's the combination of transition metal ions that we talked about a little while ago with polyatomic ions. Even though there's no new rules for dealing with those, I still want to do a couple of examples that show you how this actually works, to get a little bit more practice in doing some of our nomenclature. So the first one I want to do is we're going to take this compound, Mn2 SO4 and we're going to name this. So Mn2 SO4 First, we're recognizing this as an ionic compound, metal ion that's going to form a positive ion, our polyatomic negative ion. So here, being I have an ionic compound, I really want to think about the ions that I have. So what ions do I have? Well, I have 2 manganese ions. I don't know their charge yet from the periodic table. It's transition metals. You can't tell just from looking at the periodic table. I have 5 of these SO4 ions. So you need to make sure you know that SO4 has a charge of -2. So I have 5 of these SO4 2- ions. Well, now by using charge balance, I can figure out what the charge on that manganese has to be. My sum total of negatives, -2, 4, 6, 8, 10. That means my sum total of positives needs to be +10. That means each manganese has to be +5. So now I'm ready to name this. Positive ion first, manganese. Negative ion second, SO4 2-. What we call that ion is sulfate. Now, being manganese is a transition metal ion, I need to use a Roman numeral to indicate the charge. The charge on that manganese is +5. So that's the Roman numeral I need to use for this. So this will become manganese 5 sulfate. So I'll do a couple of these mixed transition metal ions and polyatomic ions just for more practice in doing these nomenclature problems. So another one I want to do. FeOH2. Again, we're still dealing with an ionic compound. I have 1 iron ion. I don't know the charge yet from the position on the periodic table because it's a transition metal ion. I know I have 2 of these polyatomic ions. OH has a -1 charge. Remember, that's not coming from the periodic table either. We had to memorize that. -1, -1, total of -2. That means this iron must have a charge of +2. So now I'm ready to write this name. Positive ion first, iron. Negative ion second, OH-. From memorizing the polyatomic ions will get you that this is hydroxide ion. I need to use a Roman numeral to indicate the charge that this transition metal ion has. Iron has a charge of +2, so I need to use the Roman numeral 2. This will become iron 2 hydroxide for that name. I want to do a couple of these going the opposite way, starting with the name, being able to write that formula. So we can kind of practice doing these, and you're starting to see what has to happen for each one of these. So the one I want to do is titanium 4. I'm going to do titanium 4. So 4 is IV, titanium 4 carbonate. Let's rewrite that a little bit lower. Titanium 4 carbonate. So now we're going to write the formula from this. Well, titanium is Ti. We don't know the charge in the periodic table, but that's what the Roman numeral is telling us. The Roman numeral is telling us that we're going to have a charge of +4. Carbonate, here you need to know the formula and charge for the carbonate ion. Remember, no other way other than memorizing these. It's a polyatomic ion. CO3, 2-. Now I still have to achieve charge balance here. +4 minus 2, what am I short of? Negatives. I'm going to tack on another one of these negative carbonate ions. Now I'm at +4 minus 4. Now I have charge balance, so now I'm ready to write a formula. I have 1 titanium. I have more than one of my polyatomic ions, so I must use parentheses and put the subscript outside of those parentheses. So a little bit more practice using some of these rules that we've talked about. I want to do one more example of this type. I'm kind of doing one more example of this. We're going to do nickel 2 phosphate. So doing nickel 2 phosphate for this. Well, nickel is Ni. It's a transition metal ion. I don't know its charge based upon its position on the periodic table, but that's what the Roman numeral is telling me. Roman numeral 2 tells me that it's got a charge of +2. Phosphate, I need to know the formula and charge for phosphate for memorizing the polyatomic ions. That's going to be PO4 3-. Still have to achieve charge balance. Again, you can use either least common multiple or trial and error. I'm just going to quickly do it with trial and error. +2 minus 3, tack on a positive. Now I'm at +4 minus 3. I'm short negatives now. Tack on a negative. +4 minus 6. I'm short positives again. Tack on another positive. +6 minus 6. Now I have charge balance. Now I can write my formula. I have 1, 2, 3 nickels. And for my phosphates, I have 1, 2 phosphates, so I need to use parentheses and put that subscript outside of the parentheses. So I get my final formula, Ni3PO42. So a little bit more practice in doing these. The last type of compound we're going to deal with in terms of writing names and formulas for are going to be these covalent or molecular compounds. So we just finished all the ionic compounds. So again, on the PowerPoint, there was a set of rules for naming these covalent molecular compounds. So you may want to pull that out to be looking at that as we're going through the examples. Remember, for these, no ions are present. None of these things have charges to them. because here we're not dealing with ions. What's holding the different pieces together is a sharing of the electrons. So we're looking at two nonmetals here. And to kind of go through these rules, I want to do two examples kind of side by side. Two compounds that I think you're pretty familiar with, CO and CO2. First, we're recognizing we're dealing with these covalent compounds because two nonmetals, carbon nonmetal, oxygen nonmetal. Carbon nonmetal, oxygen nonmetal. So we go through the rules. Remember, I'm not writing out any ions here because those ions don't exist. These are not present at all in these covalent compounds. First rule says write out the name of the first element, carbon. If I do that in each case, carbon, carbon. Then it says name the second element, use the IDE ending. Well, oxygen is going to become oxide. Oxygen is going to become oxide. And right away you see a problem just with these first two rules. When we look at these, so far I have the same name for these compounds. These are very, very different compounds. We definitely need a way to distinguish one from the other, especially for this grouping. One of these is kind of needed for life. The other one could potentially be fatal. So we definitely need to have a way of telling them apart. That's where that third step in naming these covalent compounds really comes in. And it's an always rule. And that always rule says always use a prefix to describe how many of the second element you have. So, starting on the right this time, here I have 2. The prefix for 2 is di. So this becomes what you're familiar with, carbon dioxide. The prefix for 1 is mono. Now here's kind of a weird language type thing. We don't put the O in there because it makes it sound weird. If you put that full O and you get the O's next to each other, it's like carbon monoxide or mono oxide. It just kind of sounds weird. So whenever it sounds weird, we drop the vowel. But this becomes what you're familiar with, carbon monoxide and carbon dioxide. Carbon monoxide detectors, we're exhaling carbon dioxide right now. Now we have a way to easily tell these two apart. Notice I didn't write any ions here because they didn't exist. And we're always going to use prefixes for the second element to describe how many of them we have. Let's quickly go through the prefixes. 1, mono. 2, di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. 10, deca. Remember, these you also have to memorize from that table in your textbook. Let's do another example of using these covalent molecular compounds that kind of illustrates the fourth rule that you sometimes have to apply. And an example of that would be something like P2S5. Right away we'd recognize that this is going to be a covalent compound. Phosphorus nonmetal, sulfur nonmetal. Okay, so we can't split up into ions because those ions just don't exist. So P2S5. So when we're looking at something like P2S5, what does the rule say? Well, name the first element. Keep the name of the element. So I have phosphorus. Name the second element. Still use that IDE ending. Sulfur is going to become sulfide. Always use a prefix to describe how many of that second element you have. Here I'm looking at 5, so that's going to be, prefix for 5 is penta. Now's that third step. Now, the last step, remember this is a sometimes step. It says if there is more than one of the first element. Remember in the previous examples with carbon monoxide and carbon dioxide, I only had one of the first element. Here, I have 2 of this first element. That's more than 1, so I have to use a prefix. The prefix for 2 is di, so I end up with diphosphorus pentasulfide for my full, complete, finished name for this. So, second element always gets that prefix. First element only if you have more than 1 of it. I want to do one more example of these covalent compounds, just going the opposite way. So far we've done formula to name. I want to do one just going the opposite way, just to make sure we're able to kind of go each way in terms of naming these. So the compound we're going to write the formula for is dinitrogen tetrabromide. So dinitrogen tetrabromide. Again, right away I'm recognizing that I'm dealing with a covalent compound. It's the first thing you always want to look at whenever you're trying to name or write a formula for something, is decide, is it ionic or is it covalent? Because you're going to go completely different ways depending upon what the answer to that is. Nitrogen and bromine, both non-metals, it's going to be covalent. So dinitrogen, so nitrogen, I have 2 of them. Bromide comes from, bromine is the root, so that's Br. Tetra is 4. So I'm looking at N2Br4. Remember, here I'm dealing with a covalent compound. No ions present because those don't exist. So I wanted you to see one last one kind of going the opposite way for these covalent compounds. The nomenclature that we did in this video is kind of complicated. This is definitely something you need to practice. This isn't generally something you can necessarily expect to just be awesome at just from watching it done. You really need to make sure for yourself by doing examples that you're able to do this on your own. And it starts by making sure you memorize those things that are crucial for doing that. Those polyatomic ions, formulas, names, charges, as well as the prefixes used for these covalent compounds, the mono, di, tri, tetra, all of those. You got to make sure you have those memorized, and then just practicing writing names and writing formulas for these compounds until you start feeling comfortable with that.